So temperature is another property that we often measure in lab, and so we need to be familiar with the units that are associated with temperature. And here on this slide, there are 3 temperature scales that we could commonly encounter. Fahrenheit is the English unit for temperature, and outside of this discussion here in lab, we really don't measure in Fahrenheit. So through the duration of the course, we really don't encounter the degrees Fahrenheit very often. We measure in Celsius in lab, so this will be a common unit that we encounter for temperature. And then once we start working in gas laws, we will be using Kelvin. Kelvin is also known as the absolute zero scale. Because in Kelvin, the zero is set at the theoretical lowest temperature that we could have. I've read a long time ago, like at that temperature, once you get there, motion of all particles would stop. And that's why I say theoretical zero. And we don't measure in Kelvin in lab, but again, we will have to be converting Celsius to Kelvin when we work with gas laws. And on the next slide, I have the mathematical relationship between those, which would allow us to do that. Now, there are numbers on this just for reference, but for as far as learning and memorizing, there are 2 numbers I want you to know. And that is the standard boiling point of water is 100 degrees Celsius. And the freezing point of water is 0 degrees Celsius. So I want you to know those 2 temperatures, the boiling point and the freezing point of water in Celsius. Now, what you might also notice, and we'll take a look at on the next slide, is that the degree sizes between Celsius and Kelvin are the same. And how I know that is that if you measure in Kelvin and Celsius both the freezing point and the boiling point of water, there's the same number of degrees, 100 degrees between those 2 points. Whereas in Fahrenheit, if you measure the freezing point and boiling point of water on that scale, you get 180 degrees, which tells me that the Fahrenheit scale, those degrees are smaller than the Celsius and Kelvin scales or degrees. So we have lots of number there, but let's look at the mathematical relationship between these different scales. So in the temperature, we're measuring how hot or cold something is, and that is what I think of as a reflection of the energy in the molecules. So when molecules have more energy, kinetic energy, they move more, and that will increase the temperature. When they have less kinetic energy, they move less, and that decreases the temperature. And so the temperature is measuring this relative motion or this relative energy. So it's kind of reflecting where the energy is. Now, the conversions between them, Celsius and Fahrenheit have a direct conversion, and Celsius and Kelvin have direct conversions. But Fahrenheit to Kelvin, you would actually have to go Fahrenheit to Celsius and then Celsius to Kelvin. So this first block is Fahrenheit to Celsius. It's actually not 2 different equations. I have just taken one equation and then mathematically or algebraically rearranged it. So one says degrees Fahrenheit equal and the other one says degrees Celsius equal, but it's really the same equation. I do not require that you memorize this equation. In fact, it's given to you on the exam table if you needed it. But in general, we don't have to convert between Fahrenheit and Celsius because we measure in Celsius. So we're usually where we need to be. Now, when we get later, we will have to convert between Celsius and Kelvin, and you'll notice that it's a simpler equation because Celsius and Kelvin have the same degree size, so the only difference is between where their zero values are, which is 273. Officially, it's 273.15. Your textbook does just use the 273, so that is fine to use the 273. Again, these are given to you. We do need to be able to convert between the two given the equations. And then now, when I look at the first equations, I kind of overlooked it quickly, but if we look back at the Fahrenheit to Celsius, this 1.8 is the difference in degree size. That's why there's a 1.8 in this one. And then the 32 is because their zeros are different. So that's why Celsius to Fahrenheit looks a little more complicated, although it's not a complicated equation, than Celsius to Kelvin, is because their degree sizes are different. So in the big picture here, you need to be familiar with the equations to use to convert between the different temperature units. You do need to be familiar with the temperature units, and then you need to memorize the boiling point and freezing point of water in degrees Celsius.